the factored forms of quadratic functions. So what you're going to be doing today is getting standard form of these quadratics and then factoring them so that you can figure out the zeros and then graphing them. So it's going to be a great time. Anyways, so to start with the warm-up, we want to just make sure you know how to factor. So remember, with factoring, you have to be able to identify your A, B, and C. So in number 1, A would be 1, B would be 2, and C would be negative 35. So when we are factoring, we use the box and X. So you draw your box and your X. You put your first term, x squared, in the top left, and you put your last term, the C, in the bottom right. Then you multiply them together, so that would be negative 35x squared. And then your middle term that's been ignored this entire time gets thrown into the bottom, 2x. Perfect. So from there, you have to decide what will multiply to get negative 35, but add to get 2. And so if you have to, you can write out the factors, but I know some of you are probably super amazing at this and can just do it in your head. 2 doesn't go into 35. I don't even know why I wrote 2. 3 doesn't go into 35. 4 does. 4 and 9. And then 5 and 7. And then that's the last one. So looking at these, because this is a negative 35, I know one of them has to be positive and one of them has to be negative. That's one thing that can help you with your signs alone, just to make sure that you can actually factor these. The next part, because they're different signs, I want numbers that have a difference of 2, and looking at my list, that would give me 5 and 7. And so remember, be super careful with this, because I want it to be a positive 2, which means I'm either going to have 7 minus 5, or I'm going to have 5 minus 7. Regardless, 7 minus 5 is the one that gives me the positive 2. And so because of that, that means my 5 needs to be the negative 1. Okay? So then you take these terms and you throw it into your box. 7x and negative 5x. And then you are just factoring every row and every column. And for a lot of you, what I noticed is you just had a hard time getting your GCFs out. So with x squared and 7x, I can take an x from both of those terms. If I take an x, I would have to multiply by x to get x squared, and I would have to multiply by 7 to get 7x. So I know my top would be x plus 7. I'm trying to arrange. There it goes. Okay, so then if I took an x, that would mean I would have to multiply by negative 5 to get negative 5x, and then your check is the last box, because negative 5 times 7 is negative 35. If you are factoring and it does not check out, like the box does not work out for every single box, when you multiply your factors together, then you did not factor correctly and you need to try again. I'm just telling you, because I've done it many a times where I've messed up. And I don't realize it until I get to that last box. So please, please, please check your answers and make sure you know how to get your GCF. From there, though, to actually solve this, we would take our factors and set them both equal to 0, because we don't care when it equals 0. We just need to know when it happens. And so we take both of these, because we know one of them has to be equal to 0. And we just solve for x. So in this case, this would be negative 7 and positive 5, because we would add the 5. Okay. Boop. All right. So for number 2, we are still going to solve by factoring. So we're going to need to do our box and our x. Remember, our first term goes in the top left, and our last term, our c, goes in the bottom right. And then we multiply those together, which would give me 3 times 24 is 72. So that would be negative 72x squared. Whoop. And then negative 14x would be in the bottom. So then, again, use some of your context clues here. This is a negative 72, which tells us that 1 is positive and 1 is negative. We don't know what yet. We also know that they need to add to be negative 14. This is where writing out your factors can help, because you know you have 1 and 72, 2 and 36. 3 I know goes into 72, but let me pull out my calculator to figure out how many times. 24 times. 72 divided by 4 is 18. And you can keep going if you want, but I kind of already know. Okay. Again, since these are opposite signs, I know I need to have a difference of 14 between them. or a possible difference of 14 between them. And so really I'm looking at this 18 and 4 right here. And so since I need it to be a negative 14, that means I need my bigger number to be negative. So I'd have negative 18x plus 4x. And so then I'm going to be putting that into my box and finding the GCF of the box. So for this top row, 3 and 4, I can't take a single number from, but I can take out an x. And if I take out an x, that would mean I would have to multiply by 3x to get 3x squared, and x times a positive 4 would give me 4x. And so then if I took out 3x from this first column, 3x and negative 18x, I would have to multiply by negative 6, and negative 6 times positive 4 gives me negative 24. So then I know my two factors are 3x plus 4 times x minus 6 equals 0. And so then you take both of those factors and set them both equal to 0 and solve them both. Yay! So we subtract the 4 on the one on the left, and then we divide by 3. Keep in mind, you are more than welcome just to leave it as an improper fraction. I'm totally cool with that. I don't mind. But when you add the 6, that gives you x equals positive 6. Okay? So, given the x-intercepts of the graph of a quadratic function, we want to write the possible factors. So here's the thing. Okay? If you have x equals 1, you really want it to be x plus or minus something equals 0, which means I would subtract the 1. And so then this would be x minus 1 equals 0. That kind of looks like what we were just doing in the last ones. And if I did the same thing to 9, I would end up with x minus 9 equals 0, which means my two factors are x minus 1, x minus 9. And this would be y equals. Okay? Boop, boop, boop. Okay. So it's almost like you're trying to get everything away from an invisible variable, aka 0. But for x equals negative 3 and x equals negative 8, again, you're just looking at the opposite signs for these. So then since it's minus 3, that would be x plus 3. And since it's minus 8, that would be x plus 8. Because if I set these equal to 0, it would give me x equals negative 3 and negative 8. Okay? So, factored form of quadratics. You've done a bunch of different forms so far. You've done standard form, you've done vertex form, and now we're throwing another form at you. Yay! But even though it's another form, all that's really happening is you are figuring out where your zeros are, because your x1 and your x2 are intercepts, and your a determines your opening and width. Okay? So, really, it's just knowing what these different forms look like and to recognize them just based on the name too, not what they look like. So if for each quadratic function we want to identify the zeros, determine the axis of symmetry, calculate the vertex, and graph the function using zeros and vertex. So first, to identify the zeros, we would just take the two factors that we have and set them equal to 0. Now, I know some of you are super awesome and amazing and can just do this in your head, which is great if you can. If you can't, there is absolutely no shame, though, in writing it out, because I know for me, I am a super visual person, and I have to. So x equals a positive 4, and boop, x equals negative 2. So that means that this graph is going to hit at positive 4, 1, 2, 3, 4, and at negative 2. Okay? Now, to determine the axis of symmetry, remember, these things get cut in half, which means if you have two zeros, you can just find the middle of them, which would be right here at x equals 1. Boop, 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 boop. Okay, so your axis of symmetry is x equals 1. So then to calculate the vertex, this is where it's kind of nice when you can just count out the axis of symmetry, because then what you can do is just plug in your 1 for x up here. So we would say f of 1 equals 1 minus 4 times 1 plus 2. Even though it's in algebra, it's still as simple as doing 1 minus 4, which is negative 3, times 1 plus 2, which is positive 3. So f of 1 is a negative 9, which means my vertex is at 1, negative 9. Ah, that looks terrible. Negative 9. Okay, so then on my little handy dandy graph, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then we just have to graph. And so the nice thing about doing this with your vertex and your zeros is that then you just get to take your pencil and draw a smooth curve through 3 points instead of calculating 5. Okay, so recap, we figured out what our zeros were, plotted them, then went to the middle of them to figure out our axis of symmetry. And keep in mind, if there's only one 0, that means that that is your vertex. Okay, like that's where it's hitting the one time. And if it doesn't have any zeros, then it doesn't have any zeros, and it's not going to be in this section. So for B, we are going to start by setting our factors equal to 0 so that we can figure out where our zeros are. And so we would have negative 5x equals 0 and x plus 6 equals 0. And so we will divide by negative 5, which gives me x equals 0. And we will subtract 6, which gives me x equals negative 6. So we will plot x equals 0 and x equals negative 6. Okay, now to get my axis of symmetry, I'm just going to the middle of them. So this is 1, 2, 3, 4, 5, 6 apart. So that means 3 is in the middle. And that's at x equals negative 3. Okay, we'll highlight all these important parts later. And so then to get the vertex, since we know it's x equals negative 3, we're just going to plug that in. And the nice thing about factored form is it's a little bit easier to deal with uglier numbers. I know that negative 3 isn't that ugly, but it helps take away your x squared and potential mistakes with that. But negative 5 times negative 3 would give you a positive 15, and then negative 3 plus 6 would give you a positive 3. So that would mean that this vertex is at positive 45, which I know that I cannot fit on my graph, but I do know that it's way up at the top. So what I usually do in these cases, especially because it's so far out, just kind of estimate, boop. And then what I'll sometimes do is just mark it and label it. So since that's my vertex, that's at negative 345. Okay, I know that's not the prettiest, and I'm sorry, but you get the idea, okay? So from there, with these graphs, we want to identify the zeros and then write a quadratic function in factored form with the given a value. So with this, my a value is 1, which makes my life super easy because I know I just have y equals x plus or minus something times x plus or minus something. Okay, usually the a would just go in the front. So then if I look at this, my zeros are at negative 4 and at 0. Well, here's the thing. I actually worked harder than I needed to. Dang it, I hate when that happens, but I love it at the same time. Because since my 0 is at 0, I can just have an x out here, right? Because I would have x equals 0. So x is there. And then to get negative 4, I would have to have x plus 4, because x plus 4 equals 0 to give me x equals negative 4. Okay, so you see, let that process. Make sure you tell me if you have questions with a comment or a message or something. Okay, but we would have y equals x times x plus 4. Okay, now for this one, because our a is 1/4, I know right off the bat I'm going to have y equals negative 1/4 because that's my first term that's going to come before anything else. Now looking at this, my x-intercepts are at negative 1 and 7. And so since it's at negative 1 and 7, that would be x plus 1 and x minus 7. Because again, you're trying to make it so that if you were to take this equation and set it equal to 0, you would get the same numbers. And so that would mean that I would have x plus 1 times x minus 7. Okay, and that's it. All right. So for example 3, we are going to factor these functions, identify the zeros, determine the axis of symmetry, calculate the vertex, and graph it using zeros and vertex. So starting off by factoring, we would have our box and our x. Boop. And so we would have our x squared in the top left, negative 15 in the bottom right. Those multiplied together give you negative 15x squared, and you would put 2x in the bottom. And so since that is negative 15, that would be one positive and one negative. We don't know yet which ones. And to get 15, we'd have 1 and 15, 3 and 5. And in my head, that has a difference of 2, and I'm liking it. And so since it's a positive 2, I would have positive 5x and negative 3x. And so then I would put that into my box. I did not give myself enough space with the box. Don't think it'll select the whole thing either. No, it won't. That's okay. But for this row, x squared plus 5x, I can take out an x from both. And so that would leave me with x plus 5. And so then if I took an x out from the first column, that would mean I'd have to multiply by negative 3. And negative 3 times positive 5 gives me negative 15. So my two factors are x minus 3 and x plus 5. And so then to get my zeros, I would say x minus 3 equals 0, x plus 5 equals 0. That would be adding the 3, which gives me x equals 3, and subtracting the 5, which would give me x equals negative 5. And so I can come to my graph and plot those, positive 3 and negative 5. There we go. And so then to get the axis of symmetry, I know it's in between these 2 points. And so to be exactly in the middle, I would need to be at negative 1 because that's 4 to the left of 3 and 4 to the right of negative 5. And so I'm going to draw it in. And again, remember your axis of symmetry, when you write the equations, it has to say x equals. Like without a doubt. If it does not have an equal sign, it's not an equation. So you have to say x equals negative 1. And so then to go from there to get the vertex, because we just have to get the vertex and then finish graphing, we're going to take negative 1 and plug it in. So we would have negative 1 minus 3, negative 1 plus 5. Negative 1 minus 3 would give you negative 4, and negative 1 plus 5 would give you positive 4, and so then that would be negative 16, which technically I guess this should be equal to y. My bad. Okay, and so then since it's at negative 16, that means my vertex is at negative 1, negative 16. And so that is not going to fit on my graph, but it's okay because we'll just label it 16. And then we will smooth curve it. Hopefully yours is a little bit smoother than mine, but it's okay. But then that is all we have to do. Yay! And this would be a minimum because the vertex is at the bottom of the U of the parabola. All right. So we're going to do the same thing with this function now. We're going to factor it first. So to start, we draw our x and our box. 4x squared would go in the top left and negative 11 would go in the bottom right. When you multiply those together, you get negative 44x squared and negative 20x in the middle. So to get 44, that'd be 1 and 44, 2 and 22, not 3, 4 and 11, 5, 6, 7, none of those work. But I do have this 2 and 22, which looks interesting. But since this is a negative 44, I know one is positive, one is negative. And since I have 2 and 22, and it should be adding to a negative 20, I know I need it to be a negative 22 because I want the bigger number to be negative. So then I put those numbers into my lovely box. And so then you're factoring every row and every column. So from the first row, 2 and 4, I can take out a 2, and then I can take out an x because they have x in common. Since I took out a 2x, 2x times another 2x is what gives us 4x squared. And then 2x times 1 is what gives us 2x. And so then, since I took a 2x from this column, I'm going to take 2x from negative 22x, which would give me negative 11. And negative 11 times positive 1 gives me negative 11. So I know that my two factors are 2x minus 11 and 2x plus 1. So then, since I have this, and I'm going to actually write y, but since these are x-intercepts, we know that the y value has to be 0. So then you're going to take each of these factors, 2x minus 11 equal to 0, and 2x plus 1 equal to 0. And so that would give you, adding 11 to both sides, 2x equals 11, and I'm not going to show everything for the sake of space. But then when you divide by 2, you would get x equals 11 over 2. With the other one, you would get 2x equals negative 1, and so then when you divide, you get x is negative 1/2. Now, I understand for the sake of graphing that it is probably easier to make these decimals, so negative 1/2 is obviously in between 0 and 1, and then 11 over 2 is 5.5, but it's positive 5.5, so we would go up to 5 and a half, and you can just estimate it to the best of your ability. But since we need to find the axis of symmetry, we're going to find the middle, which looks to be, let's see, boop, doop, trying to, oh man, it's in the middle too. I hate when it happens, but it does. But we would have an axis of symmetry in this middle because, again, you're just finding what is the average of your two zeros. And so then that would be at x equals 2.5. Okay. And so then to get the vertex, we would plug that in. We would get 2 times 2.5 minus 11. And I'm only using brackets because it helps with the parentheses I'm using. But then 2 times 2.5 plus 1. And so then when we plug in 2.5 to get our vertex, we'd have 2 times 2.5 minus 11 times 2 times 2.5. And so that should give us negative 36. Does that sound about right? That'd be negative 6. Sorry, I tried to type it all in at once on my calculator, but now I'm realizing that made it worse for me. But yes, because it's negative 6 and positive 6, so then it'd be at negative 36. And so then just estimating, this would be negative 2.5, or no, not negative 2.5, positive 2.5. Negative 36, though. And then your parabola would come down and around like so. Okay? So our closure question is, where is the vertex located in relation to the x-intercepts of the graph of a quadratic function? Explain your reasoning. Well, your vertex is going to be in the middle of your x-intercepts. The middle of x-intercepts. But keep in mind, even though it's in the middle, it might be higher or lower than the x-intercepts. So when you have, let me draw 3 graphs, because you will have obviously the case where you have no x-intercepts, so this doesn't apply to those. You have the case where you have 1 x-intercept, which x-intercept is the vertex. And then if it hits twice, like so, then it's in the middle. Okay? So if you have any questions from this section or this unit, or something's just not quite clicking, please leave a comment below or send me a message or get a hold of me in some way, shape, or form, because I do not want you to be confused on math, because it does not have to be scary. But give the video a like if it was helpful, and give the channel a subscribe if I am helpful in your math learning, so that you can continue getting notifications when I put out more videos.